Dear colleague, I represent report geometric digital twin of a partially destroyed high-rise buildings. The authors of these reports: Yuri Kaliukh, it's me, Olga Tytarenko, senior researcher, Vladimir Tytarenko, head of department, Mikhail Yakovenko, professor, Victoria Vapnichna, senior researcher, and Yaroslav Berchun, senior researcher. We represent Institute of Telecommunications and Global Information Space of National Academy of Science of Ukraine, National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnical Institutes, and State Enterprise, the State Research Institutes of Building Constructions. The damaged multi-story buildings on 5th Vyacheslav Chernavila Street in Chernihiv, Ukraine, is a monolithic reinforced concrete frame buildings. You can see on the figure 1. It was damaged as a result of an air bomb hit on March 3, 2022. The sections of the 13-15 floors was destroyed with the collapse of the floors. Due to the damage to the pylon at the stage of initial inspections, there was a possibility of deformations of the upper part of a building's frame along the spatial vector. Deflections of the floors are possible due to damage to the spectrum and excessive load from the destroyed slabs. The technology of assumed and control of the technical conditions of damaged multi-story buildings include preparatory and planning work, which include, at this stage, the object of a survey is studied. The structural features of the buildings, types, cases, and consequences of damage are analyzed. The existing design and construction documentations is processed, and potentially dangerous areas are defined. A preliminary visual inspection with photo fixations allows you to clarify the scale of damage as well as plan the scope of geodetic work. The result of this stage is technical task for conducting an assessment of the technical conditions. Second, assessments of the technical conditions of a damaged multi-story building. During the assessments of the technical conditions, instrumental measurements are performed to quantitatively determine the spatial parameters of the formations. Geodetic methods are used to determine the vertically and horizontally of load-bearing elements, measure slopes, and horizontal displacements of walls, columns, floors, slabs, etc. Based on this data obtained in the zones of degrees deviations are established limits of spread of effects of explosion, impacts, fire, unstable constructions, and so on. Technical conditions control, time monitoring. Systematic monitoring of deformations in dynamics is carried out. For this purpose, control periods of observations are established and repeated level measurements of horizontal displacements and observations of development of the opening cracks and seams are performed. The constructions of a digital twins of a damaged multi-story buildings was carried out in order to create a correct calculations and analytical model. The numerical model reproduces the real stress-strain state of structural after a missile strike. On the next slide, you can see the first stage for creations digital twin. You have physical object on these parts, you can see, and digital objects. On this stage, where we create only digital model, we know continuous connections on these parts, on right parts, and on reverse paths. No, with the no continuous connections. On the second stage for creation digital twins, named digital shadow. On this stage, we have continuous connections from a physical object and digital objects. What does it mean? On this stage, and we use in our report, we correct initial boundary conditions from the real situations. Under rocket attack, we have some destructions of the buildings. We may conclude with destructions in our mathematical model to conduct the correct calculations. If we correct our initial bound and boundary conditions, which named digital shadow, where exists continuous connect between physical object and digital object. On the third stage, this is a full digital twin, where we have right continuous corrections and reverse continuous connections or feedback. On this slide, you can see the model of strain state of damaged multi-story buildings. Numerical technology based on finite element methods was used. It used the geometrical digital twins of building number 15A on the Vyacheslava Chernavila Street, Chernigov, Ukraine, as a correct boundary conditions. You can see this geometrical digital twin of this high-rise building. On this slide, you can see general view which digital twin fragment of a house in other parts in Kiev, 37 Vladimira Lipkivskого Street, according to the design data without taking into account damage digital model. You can see the absence of building elements on these parts of the building. This is the correctness or digital shadow of this building. On this slide, you can see the table list of relative marks and vertical displacements of a Mars installed on the ceiling of the 14th floor of the damaged multi-story buildings during the period from August to December 2022. Four survey cycles were performed, namely the first cycle August 23, second September 15, and third November 17, fourth December 28. The explosive impact occurred inside the building below the floor level and caused the floor to rise by up to 100 millimeters. The minimum values of vertical displacements are concentrated in the central parts of a room, while the maximum values are observed near peripheral zones. Based on the results of observation, a list of relative Mars values of vertical displacements of Mars was completed in the table 1. You can see the table 2 digital twin of a damaged multi-story buildings for assessing its technical conditions and restorations, which include objective assessments of technical conditions, identifications of critical areas, planning of restorations measurements, integrations with monitoring system, decision supports, and scalability. You can see on this slide. Conclusions. A geometrical digital twin of a damaged multi-story buildings was built, which was used for refined assessments of its technical states and economic damage in the future. The methodology for deformation monitoring of damaged multi-story buildings using combined geodetic methods was fully developed. The practical applications of a digital twin allowed combining the results of geodetic, visual, and non-destructive research in the innovative technology construction 4.0. This provided the possibility of structural health monitoring and quantitative assessments of the current technical conditions of damaged multi-story buildings structures, numerical modeling of the deformations, and developments of scientifically based recommendations for restorations of partial dismantling of individual damaged building structure of damaged multi-story buildings. Thank you for your attention.